So most of cases the gases are not obeying ideal gas equations. So Van der Waals conducted detailed study on ideal gases, and he concluded that some of the postulates from the kinetic theory are not right in all conditions of temperature and pressure. So Van der Waals introduced a correction factor for pressure and volume in the ideal gas equation, and it derived a new form of equation that is known as Van der Waals equation for real gases. So here, ideal gas equation PV is equal to nRT for n mole. So Van der Waals made a detailed study on the volume of individual gas molecules and the intermolecular force of attraction. Intermolecular force of attraction between gas molecules. So according to kinetic theory of gases, the volume of individual gas molecules are negligible compared to the total volume of the gas. But Van der Waals made a detailed study on that, and he explained some conditions like if you increase the pressure of a gas, so the volume of the gas decreases. So if you increase the pressure, in that case, the individual molecule's volume cannot be neglected. That means the volume of the individual gas molecules cannot be neglected at a high pressure and low temperature. So if you increase the pressure and lowering the temperature, the gas molecules can be liquefied. And further, if you increase the pressure and lower the temperature, the liquid can be solidified. So in that case, the volume of individual gas molecule cannot be neglected. There is some volume for individual gas molecules. So Van der Waals introduced that correction into the real gas equation. Secondly, according to kinetic theory of gases, the intermolecular force of attraction between gas molecules are considered to be neglected. That means there is no intermolecular force of attraction between gas molecules. But if you take as an example a balloon with a gas or air, if you try to press that balloon, that means if you try to reduce the volume of the balloon by pressing or increasing pressure in another way, the gas molecules get stressed. And if you put a hole on the surface of that balloon, what happens? The gas inside the balloon tries to expand into the atmosphere of low pressure compared to inside the balloon. So there is a cooling effect takes place. Why that cooling effect happens? When a gas is released from high pressure area to low pressure area, the gas molecules uses some energy to do some work to overcome the intermolecular force of attractions. That means the gases at a high pressure and low temperature possess a definite amount of intermolecular force of attraction between individual gas molecules. So according to Van der Waals concept, that intermolecular force of attraction cannot be neglected. That also need to be taken into account in the ideal gas equation. So Van der Waals modified by introducing correction factor on pressure and volume like A by V square and B. So we got a new form of an equation for a 1 mole of a gas, P plus A by V square multiplied by V minus B is equal to capital RT. So here A and B are Van der Waals constants, and A by V square is the correction factor for pressure and B is the correction factor for volume. So this is about the Van der Waals equation. So here when we look into this graph, if we plot PV divided by RT against pressure, the dotted line indicates ideal gas equation. That means ideal gases are always travel in a straight line. But the real gases, some other gases, hydrogen and carbon dioxide, hydrogen shows the positive side of the graph. That means the upper side of the ideal gas, and the carbon dioxide shows a negative dip and then goes up. So there is a deviation from ideal gas behavior. That's a reason for introducing new equation for real gases. And the gases which obeys this equation are known as real gases, or gases which doesn't obey ideal gas equation are known as real gases. So I would like to summarize some points between ideal gas and real gases. Ideal gases are always obeying an equation PV is equal to nRT at all conditions of temperature and pressure. But real gases are not obeying that equation but obeys Van der Waals equation. P plus A by V square, V minus B is equal to RT. So secondly, in ideal gases, there is no intermolecular force of attraction between gas molecules. But in real gases, there is a certain amount of intermolecular force of attraction between gas molecules. And in ideal gases, before finishing, I would like to summarize 3 or 4 points about ideal gas and real gases, what we have discussed here. So first one is ideal gases are obeys ideal gas equation at all the conditions of temperature and pressure. But real gases are not obeying ideal gas equation but obeys Van der Waals equation. Secondly, ideal gases not possess, or in ideal gas concept, the individual gas molecules have no any volume compared to the total volume of the gas. But in reality, the individual gas molecules have certain volume. Third point is, in ideal gas concept, the intermolecular force of attraction is zero between gas molecules. But in real gases, there is a certain amount of intermolecular force of attraction. So I think that's about ideal gases and real gases.